Hello, everyone. Welcome to episode 256 of the Day Zero podcast. We're continuing on with our bit of test episodes with doing some more discussional content over the deep dives on the vulnerabilities. So, once again, we are asking if you do have any feedback, do feel free to leave it in our Discord or in the comments section or wherever, as we are still kind of exploring changing the format a little bit.
Yeah,
But
I
yeah,
mean,
so
I just kind of appreciate hearing, especially those of you who listen to us more on the bug bounty side. Again, we kind of have a few more lower level topics, I guess. I mean, arguably. So I'd be interested to hear for those of you on that side if there's value in this or if we should try and focus on getting some other content in on these episodes too, which we do plan to still cover bounty and a mix of content, but yeah, I really appreciate the feedback. Negative
yeah.
and positive.
Yeah, we'll get started here. So we have a few topics today, one of which was from Trail of Bits and is titled Friends Don't Let Friends Reuse Nonces. So, as you might expect with that title, this is about cryptography, which is a topic that we like to talk about on the podcast from time to time because it's a very obscure area that a lot of people like to consider magic. And this blog post actually helps you see through some of the magic a little bit with some of the diagrams, which is why I know you liked it, C. So I'll let you take the lead here.
Yeah, the big thing that I saw with this post, well, the reason I wanted called out is honestly just one of the graphics here really illustrates the problem uh, really well and in a way I've not seen before. So kind of getting into that, nonce reuse, nonce is kind of, it's meant to be like a number used only once. Nonce is kind of where that comes from. The idea being it is some sort of unique number that's unique to this usage of the crypto and should change. You may be able to kind of think about it. Its use case similar kind of to an IV where it should also be unique, but its use case, or at least where it's called the nonce, in this case specifically with CTR mode with AES or like cha-cha being used kind of in that context where you've got your kind of stream cipher being set up or trying to create something out of that or create a stream cipher out of the block cipher in case of CTR. Um, so it's that specific use case of nonce, and they start off with this classic kind of crypto problem example where it's like, well, you can encrypt your data, and they use this example, classic example of the problems with the ECB mode, electronic code book, where you have this picture of tux, which is kind of very distinct. Usually uses a very large image. It has a lot of white blocks, a lot of black blocks, and then some other colors mixed in there. And then when you
Has a lot of
encrypt that,
contrast.
yeah, well, a lot of contrast and importantly, a lot of repeating blocks of information, because
Yeah.
crypto works on the blocks of data as you go through. So, not necessarily every pixel, like maybe you've got 256 bit block going on or 128 for AS 128, more common, but you've got like the block set up there. It's going block by block. So when those blocks are being encrypted by the same key in ECB mode, it does nothing special to try and hide this, so you end up with the second image, and for our listeners, basically you end up being able to see, oh, this is like a pure white block being encrypted, this is a pure black block being encrypted. Like, you could see those values or those blocks being repeated even if you can't tell what the real data was. You could tell that like this data is repeated throughout the entire encrypted message, and that's kind of the important distinction you can make there. And while I'm thinking about it, that kind of distinction and that notice is actually kind of the foundation of one of the crypto challenges that I made for 0x539.net, which is old challenge site that Spectre and I worked on.
Hasn't been updated in some years, but the
I
challenges are
keep
still
it
cool that are
running.
there. Yeah,
Yeah,
we keep
I
it
keep
running.
the thing running, so it's at least there for
Um,
that reason. But yeah, so I was trying to pull it up here for the link. There we go. So yeah, it's a challenge that's based at least in part, understanding that idea. Although nowhere near as complicated as what this post gets into. This idea from the ECB mode that repeated blocks, or really the block idea, is what's on there. So if we want to play around with that, I think it's a fun challenge. It's one I'd like to use to introduce people to like problematic crypto. So coming back onto this post, for the nonce value, kind of introduced nonce as being this idea of kind of being what creates the noise in your image. And so they have the example where, they again encrypt this tux image, and they have the pseudo randomness coming in there from this nonce, and you can kind of see, well, really you can't see. It just looks like random bits of data being interpreted as an image. It looks like, snow, or uh you know nothing really discernible. And then it's the second image here. Fortunately, this is kind of a visual thing, so for those of you listening, you won't necessarily be able to see this, but I'd recommend, checking out the video or going to the post and checking this out to actually see what this looks like. But you can kind of see as this image changes, you'll see that same old outline of tux where there was like the repeated black areas. And you'll be able to see how the noise, even though it still looks encrypted and still looks like noise, the noise is still there when you're repeating the nonce across. Well, technically they go into a little bit more detail on how this works, because what they're doing is they're doing like a differential cryptanalysis. They're taking the output, XORing it with known value. It's a little bit more complicated, but this illustration over how the data changes or doesn't change depending on that nonce, I thought was just a really good illustration that I wanted to call out. Okay, we're not going to dive into all of the crypto here, although you can kind of go into uh the posts here. I think they do a great job of explaining it, and then they actually go a little bit further to show how you can do the differential crypto and get back this weird little XOR tux and uh BC.
BSD.
Yeah, the name
Yeah.
slipped me for a moment. The XOR the two messages, so then you're able to kind of recover the XOR of the messages, which is the standard differential attack, where you can kind of tell the difference between messages rather than recovering the message itself. Although in this case, that differential is enough to kind of tell you what the messages were. Uh, so yeah, I thought it was just a really cool showcase of this issue, because at a glance, like if you just took any output from the crypto and you looked at this, like you look at this image, you would assume this is like, there's nothing here
You'd
that looks
assume you're
like
safe.
problematic. Yeah, it looks
Yeah.
entirely random. It's not something obvious like the repeated blocks like we have in that first encrypted image. It looks very random, but there are these other issues to it, and like I said, I haven't actually seen it illustrated this way, and I really like that illustration.
Yeah,
Um,
it's an awesome way of demonstrating the subtle problems that you can have with bad pseudo-random implementation. And it's a good demonstration of why, like, even going back to the AES modes with ECB versus like CBC or CTR or whatever. I mean, they're talking about stream ciphers, but that's the reason why you basically don't want to use ECB on any data that goes beyond like one block size, because you start to pick up on those patterns. ECB is fine to use if you're using AES 128 and your input data is less than or equal to 128 bits. You're fine. As soon as you start going over one block, that's where you start getting these patterns and problems. So that's why the other modes like CBC came along, where it'll chain um, keys together for each block. That way you keep the one use per block mentality there. So it's easy. Like if you're just using crypto and don't think too much about the underlying mathematics, or just don't care to, um, it can be easy to not really understand why that's needed. And I think this blog post is perfect for explaining why you have to go through that effort of making sure you're only using things once. It's just, yeah, like you said, it's great. It's a really cool post.
yeah, and I will kind of slightly correct there. Like, technically, this isn't bad pseudo randomness. Like, randomness isn't the problem here. Like, it's starting the randomness in this, like, repeated seed sort of deal.
Yeah, that's sorry.
Um,
I should have phrased that a bit better. What I meant was like using pseudo randomness properly is a hard thing to do, and this kind of explains why.
yeah, it's hard to eyeball and really see when there are problems in randomness too. Um,
Yeah,
so that's why, like, even though technically maybe not entirely accurate to this post, that same idea of just randomness, kind of like problematic pseudo randomness, can still look very convincing in a lot of ways. Um, so yeah, like you kind of started off this talk mentioning there, this is one of those areas I think a lot of people look at with as a bit of like black magic, as a bit of it's too complicated to get into, so it looks okay, so we're just going to assume everything's fine. And in fairness, one of the challenges also with crypto is that so many crypto problems just aren't practical, especially in the sense of like if you're doing bug bounty hunting, or if you're like doing a red team engagement. I had talked about uh, before the episode, I had mentioned how there's this one attack, like, yeah, you could do this thing. It just requires that you're connected to the same website for a download of like 750 gigabytes of data, and then you can leak the cookie. It's like, there are some of these crypto attacks that are really only kind of technically attacks, because mathematically speaking, it's considered an attack as soon as you're able to do something kind of faster than brute force, even if it's like 5 operations faster than brute force. It generally
even if
breaks
it's still
down that. But
unreasonable. Yeah,
yeah, exactly. So you end up with a lot of crypto attacks that are pretty unreasonable or impractical. Even with that in mind, like, there are still kind of practical crypto attacks, and it just kind of depends on the situation you land in to say, hey, is this actually like an issue we can take advantage of? And just being aware of and actually looking at it, because I do feel like crypto and randomness is one of those areas that just gets easily overlooked, because it does require, a bit of that background knowledge, a bit of digging, and a bit of actual thought and understanding to come up with an attack. Um, a lot of, like, sometimes you could just kind of replay the same old thing, but sometimes you really have to understand what this data is in the first place to figure things out with it.
you need
And
to be
that
aware of all the
means,
context. Yeah,
yeah. And so that creates kind of a complexity around it. But I definitely think it's an overlooked area. Although, again, a lot of times, like a lot of crypto uses, don't encrypt as much data as you would need to like break some of these things too. So, not necessarily as practical you'd like, but still fun illustration. And also kind of leads into a little shout out I had. I found out just recently that one of the books I always recommend when it comes to crypto, learning crypto for anybody in security, is this book, Serious Cryptography, from No Starch Press. Apparently, just in the last few weeks, they put out Serious Cryptography second edition. First edition, I think, was like 2017, I feel like. Maybe it was 2018. So it's not like super old, but still, they put out an update to it, which I'm kind of excited about. I really like this book. One of the things I like about it is, unlike, cryptography engineering, some of the other classic recommendations, which are still solid when it comes to being a developer getting into crypto, but coming at this from a security, like, auditing analysis perspective. I like this book because it really seems more focused, or at least it has more information just about here's what goes wrong and what you can look for in a very kind of practical sense. And this expanded version goes into some like blockchain and like cryptocurrency type crypto issues also. Not like a DApps, not the decentralized application bugs, but like fundamental crypto issues still, but kind of adds that in. I haven't had a chance to like review everything that's new in it, but the fact that it's been updated, want to at least shout it out for those of you who do want to, start taking a look at some crypto. I'm a big fan of this book.
all right, so getting into the second topic. So Microsoft hosted a Windows Endpoint Security Ecosystem Summit recently, and this was sort of prompted by the CrowdStrike disaster from July, which I'm sure everybody listening is aware of that happened. And Microsoft ended up taking a lot of the blame for all these systems going down because, of course, they did. It's their operating system and everything, and they didn't like that too much. So Microsoft is looking at avenues to ensure that something like the CrowdStrike incident doesn't happen again, as well as just trying to improve Windows resiliency to bad driver issues and stuff like that. So at the summit, they talked a little bit about like the safe deployment practices and improving that with their partners and whatnot. But what's a bit more interesting and what's got people talking is that it seems like they're looking at locking down the kernel a little bit more so that EDR products like security products can't run in the kernel, or at least can't do as much in the kernel, as well as things like anti cheats and things like that, kind of taking the power away from them to cripple the system, which, in my opinion, is a good thing. But there's a lot of debate around that, and
So I think there's
yeah,
been
so
some talk with regards to the anti-cheat, but I'm not sure if anti-cheat actually gets mentioned officially here.
it's not mentioned in the Microsoft blog post, no. But they are sort of being caught in the crossfire, so to speak,
I mean,
because they do similar things to what like EDR products do.
I imagine so many things that like basically anything that isn't a device driver is going to get caught or can get caught up in this. Anything that isn't like a physical device thing, basically.
Something for talking to a device, which is what device drivers are meant for.
Yeah, well,
Um,
basically anything that isn't going that route, though, like all of the software that's using kernel mode as a way of providing extra or like, the anti-tampering, the features that they want there. Actually, anti-tampering's one of the things that gets called out here, but yeah, basically anything that's using it in that way would get caught in the crosshairs. So that includes anti-cheat.
yeah. So to be clear, we don't have technical details of what's in the plan, so to speak. They don't actually even talk about if anything is set in stone yet. They've just kind of been talking with the vendors, and there was a general consensus that like, hey, this we do need to improve on this. Make sure that the operating system is reliable and can't be brought down on a mass scale like that. Um, and yeah, there was back and forth. Microsoft actually includes some quotes from some of the executives at these various security companies that run things in the kernel, and some of them say like, we're hopeful that they will allow us to keep this level of access to keep customers secure and all that kind of stuff. But kind of why I wanted to talk about it is there's a lot of it seems like there's a lot of fear by the security people that this is going to diminish their product. And part of that is, like Z said, they like to have the anti-tampering stuff in the kernel because Microsoft doesn't really provide a great userland protection in the way that if you're running your security product in user space, it's pretty easy for another product generally, especially if the user is willing, or if you have a high enough level of access as an attacker, to just take over that process, or tamper with it in some way, which is why these security products like to go in the kernel, because the kernel is more difficult to tamper with. It's not impossible, but you do have sort of that boundary, that security boundary that gives you a bit of safety. On the flip side, you're running code in the kernel, so any issues, whether they be security vulnerabilities or just straight up bugs that cause crashes, brings down the whole system, which is obviously what happened in July. So I understand Microsoft's position on wanting to cut some of these drivers out, or at least reduce what they can do in the kernel, because honestly, I don't think a lot of these developers should be writing kernel code.
There's
Not
so
to be like an
many
elitist,
terrible
but
drivers.
like, yeah, like kernel code is difficult to write in a way that's good. Like it's hard to write good kernel code. You have so many considerations to take into account
Well, I
because
just
of the
think
level you're
of
operating at, and a lot of bad code ends up getting at that level, and I think it's good that Microsoft is looking to take steps to stop that.
yeah, on one hand, I'm kind of in favor of the idea of Microsoft actually providing more functionality to the user line to be able to protect itself and take advantage of
I
kernel
agree.
features. And that actually, in one sense, it will increase attack surfaces. It increases the complexity of the Windows owned kernel core. But it also reduces some of the attack surface because insecure drivers are a massive attack surface and are like notoriously insecure on Windows. Like there's just kind of crappy drivers. I forget which driver or like who manufactured this one, but we covered one on the podcast long ago, and the vulnerabilities in it were just like, basically you had like primitives that gave you read write access to some of the like manufacturer registers, and like just from user lab, like you could basically take over the machine because of basically copy and pasted code from this like sample driver. I forget what the name of the like product that was copied and the product that was actually using
I,
it, but
I'm I'm pretty sure it was some gamerware
it
garbage,
was a
like
gamer
RGB
thing.
stuff.
Yeah.
Yeah.
It was one of those types of drivers. I just don't recall who it was. And like the driver they copied has a name. It's been copied by a bunch of other things too. They're not the only one who have done that, but like just notoriously insecure things have landed in the kernel.
Yeah.
In
And
this
it's good to move
case,
that responsibility to Microsoft developers who work in the kernel. That's like shifting that responsibility and then making it into an API is a far better way to go about it. Sorry, go ahead.
to provide some of that. Although at the same time, it is also then blocking users out of being able to do what they want with their computer. Um, Especially because this is the sort of thing that can be used anti-cheat, DRM, those sorts of systems that, maybe some of us aren't the biggest fans of. And it's another step kind of in that direction of weakening the power the owner has over their own machine. When it comes to Windows, I kind of feel like, kind of lost a bunch of that just when it came to needing signed drivers by Microsoft or needing to have a blessed driver. Obviously, you can get around that on your own system. I believe you can still boot, or like you get the big old warning when you boot and everything, but I believe you can still boot with some unsigned drivers if you wanted to for yourself.
You can turn
Although
on
I
secure
think
boot.
it's
Yeah.
yeah, but I believe it's quite a hassle to do that. I haven't done that in forever personally, so I don't recall the actual process for it. But I imagine that would be the same, perhaps the same case here, where um the default protection is going to be there, but users will still kind of have a way around it. Should they want it, I would kind of hope that'll still be the case. Because otherwise, like I do see a legitimate concern when it comes to reducing a user's ability to do what they want with their machine, even if I don't personally have a good use for that. And I do think it's better for security, but there is always that kind of trade-off. Like I don't want PCs to become like a Android system where you can't really, well, you're, I guess Android's better because you can sideload, but not leading into the gate kept environments really.
The walled
Um,
garden. Yeah.
yeah, the more the kernel takes over and the more you put there, the closer you are stepping towards that. But nonetheless, I do think, at least for the security products, because another thing is security products are notoriously insecure. Like that is also a thing. So with that in mind, the idea of having security products in a less privileged position and not running right in the kernel feels like a better move to me. So on a whole, I do, at least given what we have here, I support the theory. We don't have any of the technical details. We don't know how they plan to do this, what they plan to provide, what anything will look like. So, it's hard to say anything with certainty. But I think the move towards limiting what happens in the kernel and getting things out of the kernel and kind of reducing uh garbage code or arbitrary code in the kernel is a positive step in terms of security.
Yeah. I think the security trade-offs of reducing the attack surface outweighs what these security products provide, honestly. I will say I don't really use them or look into them that much, so, take that with a grain of salt. But as you say, we have, over the podcast, the life of the podcast, we've seen these drivers a fair amount, and it got to the point where we stopped covering them because the issues were very boring. They were straight up giving arb read write primitive type things because the code was just crazy bad. So yeah, so on the other side of this, from like Microsoft and the users, it seems like anti cheat companies and the security companies are worried, if not outright angry. There's not a lot of positive thinking on that side towards these changes because they like having the ability to run their stuff in kernel, and they're kind of arguing that like, hey, if you remove our ability to keep the stuff in the kernel, we're screwed. We can't guarantee the integrity of what's being ran. And like I kind of wanted to counter that argument a little bit in this discussion because, kind of like what you said earlier, you can disable secure boot fairly easily. So for anti cheats, especially, I think it's a dumb argument because, like, when you consider cheating that's using like DMA, for example, uh, when you're talking about that level, your kernel driver isn't doing very much. In all honesty, like it's if someone is in that position where they're self-attacking basically, there's a lot of avenues they could go to get around your kernel driver. So whether or not you have to use a Microsoft provided api and do it in user space versus the kernel isn't going to make much of a difference, if any. So I think it really is just that, oh, we've been doing it this way forever, we don't want to have to change it. I think that's what a lot of the rationality behind that is.
So
On the
the
security
safe
product side, I get it a little bit more. But even still, the same argument applies. Obviously, it might be harder for an attacker to get the kernel level access or above kernel level access to do things than it would be for a self attacker in the case of cheating. But even still, uh, whether or not you're using the APIs, you're running at basically the same level of risk. So,
when you
sorry,
mentioned
go
like
ahead, Z.
the safe boot being disabled, like I'm pretty sure any cheats will detect that, recognize that hey, this wasn't booted along like the chain of trust isn't there, whatever.
So they
Um,
will. Like Vanguard, for example, which is the one that everybody likes to point to as like the pinnacle of any cheats, kernel level any cheats. They will detect if secure boot is disabled and it will refuse to load. You won't be able to play if secure boot is disabled. Um, but as we have seen over the course of like the DEF CON presentations we've looked at and stuff we've covered on the podcast, even if you leave secure boot on, it's not very hard to subvert it.
yeah,
Because again, vendors are providing bad code that's running in UEFI modules. So if you can compromise it at the UEFI stage, you can still compromise secure boot early on enough to still compromise the kernel.
I mean that's kind of where I wasn't actually going to go with UEFI level compromise. That's why I mentioned just other drivers being abused. Because I just
Or
think
that
of
too. Yeah.
apparently there's recently a ransomware that used so in my head I'm thinking it was an anti-cheat driver, but now that I'm thinking about it, I might be mistaken about what the driver was. But it had used some like somewhat popular driver that also cheat developers were using to get around the anti-cheat by using that to get their privilege access. So like a lot of devices, as we already were talking about, like there are a ton of insecure drivers. So taking steps to reduce the drivers and how many drivers you need that have potentially insecure code is, I think, ultimately a positive. But
It's
Microsoft
better
does
for
need
everybody.
but Microsoft does need to step it up and actually provide those primitives that allow them to still offer some degree of, anti-tampering and all of that. Like they can't just like take it away and leave you with nothing. They need to offer some that really isn't being offered, I think. Uh, like on any operating system at this point.
Yeah, but I think it's safe to assume that that is what the plan is because that's why they hosted this summit, right? They are talking to these different companies and trying to come up with a cooperative solution, rather
We
than
don't
just
have the
taking out
information.
their access. Well, if they were just going to take out their access without providing anything else, why host a summit on trying to figure out how to take next steps,
I'm
right?
right there with
So
you. I agree with you. That's probably what's going on. We just don't have the information, so I'm tossing it out there as. But we've got to see what they do, and like
yeah, most of what we're
how
doing here
well
is
they do it.
speculating.
Yeah.
Yeah. But yeah, I guess the way I would wrap it up is I think it's better for everybody to reduce the attack surface than it is to keep the attack surface the way it is and keep this bad code in the kernel. Uh, for the sake of a few of these security products. Like, it just doesn't make sense that way. So yeah, I'm kind of excited to see what Microsoft is going to do. When we do get technical details on what their plan is and the kinds of APIs they're going to set up, maybe that's something that we can cover again on the podcast. I wouldn't expect that to happen anytime soon, especially in Windows world. Things move pretty slowly because you have so many more vendors and stuff in the ecosystem. It's a very common OS. You have enterprise where things have to work.
Backward
So
compatibility has been one of the big
that too.
drivers towards like, drivers being so insecure and stuff. Is just kind of holding everything back at Microsoft, really, because that's one of the things that makes Microsoft very different from like the Linux world, where in Linux, you do still have some proprietary drivers, like I believe NVIDIA does the one. Like there are some, but most of the drivers that you're going to use aren't just these black box binaries that get installed, but are actually included as like part of the kernel and are in tree at some level.
Yeah.
And so because of that, when they make like some sweeping change to the kernel, they can go and change all of the driver code at the same time and like make these sweeping changes that just aren't really possible on Windows.
Yeah.
At least while maintaining backwards compatibility, aren't really possible on Windows.
Yeah. And one thing I'll say too is with a lot of the stuff Microsoft has done over the last while with like secure boot and virtualization based security and VTL1 and like their secure kernel and everything, I do think they could make a pretty good API and make some changes to make it fairly secure to the point where it at least provides parity with being able to run the code in the kernel without the drawbacks of the potential consequences of that. So yeah, I am pretty hopeful on this, but I wouldn't expect to see details on it or anything for a while. So I did want
Yeah,
to talk about
like
it a little bit and talk about some of the technical details because it's been talked like this post and the media that's been circulated around it has had a lot of discussion about it. And I like to look at a bit more of the technical side and consider like, do they need to run in the kernel and could capabilities be provided to move it out of the kernel? And ultimately, I think yes.
yeah, I think they could. I'm kind of excited to see what Microsoft does put out on that front in terms of what they do
For
think of
sure.
in terms of an interface for that. Um, Especially depending on how big of a picture they go, like there could be some interesting things coming out of it, or it might kind of just be nothing.
Yeah, you could kind of see it going either way, but there's some very smart people working behind this that want change, that have been kind of held back by other players in the industry, and it seems like CrowdStrike was kind of the match that lit the fuse to actually inspire change. So that's exciting. And something good that came out of that whole debacle. But yeah, that's the main topics that we plan to cover. Z, I'll let you get out any last parting thoughts and then we'll wrap it up.
Uh, yeah, no real parting thoughts for this episode. As usual, we appreciate the feedback, and with the changes, we do want to hear if you're really want us to go back to just vulnerability summaries or something. Let us know. um, but yeah, nothing, no shout outs or anything besides Series Crypto.
All right, cool. So, with that said, thanks goes out to everyone who tuned in. Once again, we do appreciate feedback on these episodes, whether it's in the comments or our Discord, and we will see you on the next episode.